Hello and welcome to Web Math Academy, where today we're going to discuss the topic of limits. Now, the study of limits is a good introduction into the world of calculus. And one example will show the procedure for you. Here we have the limit of the function x squared minus 1 over x minus 1, and it's as x goes to 1. What that means is we're looking for the value of this function as we converge on x equals 1. Now we should note that there actually is no value right at x equals 1, since that would make the denominator 0. But we can make a table of values to get as close to x equals 1 as we want. And I have a table like that right down here. So we start from the left with 0.5, and if we plug that into x, we get 1.5 as the value of the function. 0.9 gives us 1.9, 0.99, 1.99, 0.999x gives us the function value of 1.999. So you can see that it gets closer and closer and closer to 2. We can also come from the right side, starting at 1.5, which gives us a value of 2.5 for the function. 1.1, 1.01, and 1.001 gives us a value of 2.001. So you can see that as we come to 1, the limit of this function converges on 2. We can use the TI-Nspire calculator to achieve this result. Simply click on Calculate to get a scratch pad. Then go to Menu, 4 for Calculus, 4 again for Limit, and then fill in the values. So here, x as it goes to 1, and then here the limit, we'll put a parentheses in here for you, and it'll be x squared minus 1, right parenthesis, divided by, left parenthesis, x minus 1. Right parenthesis and right parenthesis again, and enter. And you can see it comes up with a value of 2, just like we saw that it would over here. Now, limits can be added, subtracted, multiplied, or divided just as follows. You just simply come up with the value of each individual limit and then add them, subtract them, multiply, or divide them together. As an example, we can take the limit we've been working with and multiply it by itself, and you just take the individual values, 2 times 2, and that equals 4. And we've done this also in our Nspire calculator, multiplied the both limits together, and we get 4. So limits can also be one-sided, that is, have a different value when approached from the left or the right. For example, consider the following function. Here the function f of x equals x minus 2 if x is less than or equal to 1, but equals x plus 2 if x is greater than 1. We have that graphed over here on your TI-Nspire calculator. Here's the x plus 2 for anything greater than 1, and x minus 2 for anything equal to or less than 1. Technically, this should be an open circle here because it's greater than 1, not greater and equal to 1. I don't know how to make a blank circle there. So, anyhow, here if we look at the limit from the left side and we notate that with a little minus sign next to the 1, indicating that we're coming from the left. The limit of x minus 2 as x goes to 1 from the left side is negative 1. And that we can see right here on the graph that if x equals 1, y, or f of x, would equal minus 1. While from the right, we notate it with a little plus sign. X plus 2, the limit, as we come to 1 from the right side, is 3. Again, we can see that here, x has a value of 1, and fx value of 3. That is an introduction into the use of limits. Obviously, it's a very large subject, and if you have any questions, you can contact us on our website at webmathacademy.com. Thanks.